Chapter 5, past year, question 25. Given 25b, given px equals to ln 3x plus 6 and qx equals to e to the power of x divided by 3 minus 2, show that p and q are inverse of each other. So in these questions here, it is a proving question that we want to have to show p and q are inverse of each other. In these questions here, how we can happen to complete the proof? Please take notes, guys and girls. In this question here, they are not asking you to find what is the inverse for P and inverse of Q and then compare. That means you please jangan pergi find P inverse and then you compare dengan Q and you find Q inverse compare dengan P. This is not something that you're supposed to do. By right, the things that you're supposed to do is that you try to show by the properties inverse. And what is the properties of inverse that we want to apply here is that we want to find out when the time I have the composite of P and also Q, can we happen to get it equals to X or not? And just only PQ composite like this is not good enough. At the same time, we would like to also investigate if let's say the composite of QP. So whichever comes first, whether they equals to X or not. If both of them equals to X, then yes, confirm they are composite to each other. If just one of them, then no, it is not confirmed. And one more important concept to take note is that please don't misunderstood that, because some of the students happen to think that if let's say I have the composite PQ and QP, they happen to the same. Therefore, they are inverse of each other. The inverse of each other. And this is not correct because just composite equal is not good enough, but they must happen to equal to X. And with that idea now, let us try to calculate the composite function one by one. So let's say I begin with the idea of try to having calculation of PQ. So the idea of composite PQ is that I would like to substitute the Q into function of P. I substitute Q into function of P. And then next, by the time I substitute the Q functions accordingly, and I simplify the terms, I will finally find out that my PQ, the composite PQ, give me answer equals to X. So we have success to done the first proving. This one works. But how about the other one? So the other one, what we happen to have here is that we would like to have QP. And this is referred to substitute P into the functions of Q. And further substitutions, you happen to find out the answer here. So please be aware. This part I highlighted in green. I need to apply the knowledge on, if let's say I have an index term base A to the power of log, and coincidentally the log also base A. So whatever happens inside the log, that will be the result. And again, provided in front of the log, I shall not have any number, I shall not have any negative sign. If there's any number or negative sign, bring it inside to become the power of the hashtag. And therefore, in this case here, you realize that ln is actually log to the base E. So therefore, it gives me the result. It turned out to become 3x plus 6, which is the content inside the log. Then when the time you further simplify your answer, you find out that the QP is also equals to X. And therefore, we come to conclusion with reasoning. So your reasoning is these properties in summary. And then your conclusion is they are inverse of each other. So this is the idea on how to prove for these questions here. And please, once again, try not to find the inverse, but just use the properties. You composite in either way. in order to complete the proof. Why we need to have either way? Because in some of the situation, you may find out that, let's say you may find out that PQ, you get it equals to X, but QP is not equals to X. And this is very often to see in the case of quadratics and square root, quadratic and square root. They may not be happen to inverse of each other all the time. So therefore, this is the solution we have for question 25.